18. Thank you. Thanks for coming. I see a lot of new faces. That's good. Start the year. But it's also nice to see people coming back to the meetups. This year we have some new and some old sponsors from last year. So we'd like to thank them all. Otherwise, it would be impossible to cover the costs we have with the meetup and bringing foreign speakers as well now and then. So we have Fiercely OutSystems, FeedZai, Dynatrace, and Vorten are our gold sponsors. And we also have two silver sponsors, Sharpani and BitSite. So thanks to them. Today, we're going to have a talk by Hugo and Kasia, correct? About building serverless PaaS. I think it's going to be really interesting. They are working as software engineers at Equal Experts, and want to thank them for their effort to put this together. I know you didn't have a lot of time to prepare, so we really appreciate it. Yeah, right, there's never enough time. And just want to say 2017 was really good for the meetup. We had 13 meetups, about 500 people in total attended the meetup, and they took place at different venues, different companies, so we get different feelings of work environments. And the evaluations, fortunately, were quite good in general for all the meetups. We thank all the feedback that you can give us, because that's what can help us make this better for everyone. So you can rate the meetups on meetup.com, or you can send us an email, or come talk to us after the meetup, whatever you think is the best way to give your feedback about the meetup, good and especially bad, so we can improve. For this year, we're going to continue along the same lines, monthly meetups at least. Those of you might have seen that now and then we have a special meetup because there's a speaker in town, or for whatever reason it makes sense to make an extra meetup, but at least once a month, except in August, because no one's here. So, unless we do it at the beach, maybe. We already have some foreign speakers scheduled for this year, 3 of them. So more or less once a quarter. It's nice to have someone coming from outside, giving us different perspectives. And the first one will be in April, and it's really someone who is a thought leader in the industry, especially in continuous delivery. So we'll be announcing that shortly. And I think the second one in June and the third in October. We'll try to have different formats for the meetup. So today it's a talk followed by an open space. Sometimes it might be just open space, might be only just 2 talks, no open space. And in March, we'll probably have a different format, which will be a talk plus a very short kind of workshop exercise based on the talk. But again, more details will come soon at Meetup page. As usually, the ones who arrived before we started got a number for the book raffle, for the DevOps handbook. We'll do that after the talk. We'll raffle the book. So I don't know who is not familiar with open space. Anyone who hasn't been? That's fine. It's quite simple. There are a few, I wouldn't say rules, but guidelines. We'll start by gathering ideas of what people want to talk about. So it's a discussion space. We'll vote on the topics that people want to talk about. Can be a just generic theme, can be a problem that you have that you'd like help to solve. It's basically anything. It doesn't have to be related to the meetup topic, okay? Should be somehow related to DevOps. But we'll vote on the topics people want to talk about and then organize into groups. But after the talk, we'll come back to this again to recap. And there are a few guidelines. I'm not going to go through them right now, but it's basically saying you are free to move around, change the discussion group. If you feel it's not bringing anything or you're not contributing, you're free to roam around and go to different discussions. So we'll come back to that later. And at the end, we'll have some food, some drinks, usually pizza. We want to thank Farfetch for hosting us today, for providing the space, and they're also providing food and drinks. Thank you very much. That also is a big help to make the meetup successful. And so let's get started with the talk. Thank you very much.
Hello. So I'm Kasia, this is Hugo, as we are already introduced, and we came here to tell you how we built our scalable and secure serverless PaaS for UX Forms. So UX Forms is a beneficiary of our venture capital, and we are from Equal Experts. So let's get started. So first of all, what is UX Forms? UX Forms is a form builder, but this is not like a regular builder, like a kind of editor where you can see what you get and so on. This is a builder made for developers. So you receive a DSL, and you can use a DSL to create your form definition, everything in Scala. And by submitting this kind of form definition, you just get a running form. How does it look from a point of view of a developer? You have a interface for uploading a jar. You upload a jar with your form implementation. And in a moment, the form is being deployed to Kubernetes platform, but you don't really need to worry about. So all the Kubernetes artifacts are created, and the form is running just in around 30 seconds. So let's summarize what are the requirements of our platform. First of all, we have that quite challenging business logic. So we have to run and we have to deploy a binary, client binary. We have to give possibility to replace that binary on the fly. We need to provide isolation, we need to provide scalability, and we need to provide service discovery, meaning that you need to, out of the box, you need to get a route to the matching form. And that everything runs on bespoke infrastructure, and that infrastructure must be very easy to be managed because we are just few people. So in case we need any skills, we need to pull it from Equal Experts. So the infrastructure is really key point here. So we opted for using microservice architecture. So every form is small microservice that runs on top of Kubernetes, is containerized, and everything happens on the flight. So how do we actually run those binaries? We use Docker. And Docker, in Docker we have our own service, which is executor. The executor knows how to render the form definition and how to use everything that is inside the form definition. That executor is containerized. Inside the executor container, we have everything to run that form. That executor is also HTTP-based application. It's based on Play framework, so it has dependency injection out of the box. So once we created that image, this is also important to mention that this image. Sorry for this. All right, so the form executor has also entry point included. but it's just empty image. So it's what you should see before this appears. And then we save that executor image to the Docker registry, so we can reuse it later to use the actual form containers. So for form containers, we just add that binary with the form definition, and we call the previously included in the base image entry point script. So the entry point script knows how to handle that class path. So once we have a ready image, we can deploy it to Kubernetes platform. So for every form, we create a deployment. We also create a pod, one or more pod, depends on the scaling demand we need. For every form, we also create a service. And for service discovery, we use Ingress. So Ingress uses a form name and the service name to match between the incoming request and the form. To do everything on the fly, we created a deployer service, which is completely our service. And it talks to Docker and Kubernetes APIs. So first, we pulling the base image, the executor base image. Then we creating for image. We pushing that for image, so then the Kubernetes can use it and deploy it to the platform. And everything happens during that request currently. So of course, deploying binaries, client binaries, leads to many security risks, and many security aspects are solved by underlying Docker's architecture. So Docker provides namespaces, Linux namespaces, and C groups, and thanks to this, we can gain isolation on many levels, like processes and networks, mounting point, and so on. And to manage all the resources that are being used by the forms container, we count on underlying C grubs, Linux C grubs. And everything, all of this needs a special platform, which is very important that our platform is easily manageable. So it can be used with, can be used by many ad hoc developers without any problems. And about the platform, I will pass to Hugo.
Hi, everyone. So like Kasia said, one of the key requirements we had as 3 core developers and some other developers being pulled in and out according to business demands. We needed a way to have our infrastructure easier to use, easier to onboard new people. So everything we do, we try to focus on scripting. So our knowledge base are scripts. So we tend to, instead of writing documentation and then trying to clarify with other people, we try to script what we find. Another thing we try to do is that all the scripts themselves are safe to run. So anyone can just go there and run the script naked, no parameters. It will either show help text, the text, or it will ask the parameters that it needs, like in a wizard kind of style. So this is the blueprint of how we organize things, the phases we have. I'm going to skim through them and explain a little bit what each one does and add a few details here and there. So we have they're more or less in order. There's a base where using Terraform, we create the basic infrastructure that supports our code and then the several tools. We use kops to create the Kubernetes cluster in AWS. Now, in last December, Amazon announced Kubernetes as a service. So let's see if it allows us to drop this step. But for now, it's what we use to create our infrastructure. Then again, we use Terraform to to create and manage all the supporting resources that we need, like manage databases and things like that per environment. And then once we have that, we can deploy the actual Kubernetes elements. So the Terraform part, we leverage a lot the modules, something that I think last year was released in a new version. So we have a separate repository where we create our own modules. So the module is just a folder with the Terraform resources, and those resources can be parameterized by incoming variables, and they produce outputs. So you can easily reuse the same set of definitions in different places. We keep a single repository for all modules. We prefer the monorepo structure, so it allows us to, well, in a single commit, we can streamline the names of variables in all the modules. So once we decided to add support for common tags in the modules, we were able to do that in all the modules in one single commit, coordinating everything. And to access them, we use then tags with the module name and a new version, so we can pinpoint exactly where. So this combination of tag with version and the folder allows us to use and point to the actual module that you want to use. Also, we automate the generation of the README files of each one. There's a tool called Terraform Docs. We run it for all of them, and it generates this. So the first part, usage, is a comment in the beginning of the main.terraform, and the rest is a tool that takes care of it. It generates this table for inputs and outputs according to the description we've added, and allows anyone who wants to use a module can easily see without fiddling with the code and all the resources, and figure out what they can use, extract from the module, and they need to pass in. In regards to the base one, it's kind of the inception of Terraform. So tools like kops and Terraform, they need an S3 bucket to store their information. For Terraform, also, it's useful to have a DynamoDB to lock access to Terraform. So when someone is running, if two people run at the same time, they don't conflict with each other. Only the first one can manage. So this base is where all those things, those inception resources are created. The Terraform state is stored in the repo itself, in Git, because it's a bit of a catch-22. You need a S3 bucket to store state to share, and then you wouldn't have Terraform to create that bucket itself. So we start this base one in Git. Is the only one that we do that. And this is an example of how we use the modules that I referenced before. So it's fairly simple. This just references our repository, the folder we want to access inside, so the actual module, and the particular tag that we want to use, the particular version that we want to use. This constants is one that we have like for the common domain that we prepend to everything, the developers IPs to blacklist that can be used in different types of Terraform definitions later on. Kops itself, we chose it because it was part of the Kubernetes project. It's from the same authors and the same ecosystem, so it felt at home. It instantiates all the AWS infrastructure for you. It creates these two instances to run, installs the Kubernetes software on top of it. So it manages all that. It creates the VPCs and all the network resources, so you can choose the topology the topology that you want, and it does it all for you. It has a lot of control, so you can get fine-tuned definitions. But again, our background is development, is not operations. So we tend to leverage as much defaults as we can, and then only drill down on customization when we feel that what it gave us wasn't sufficient. So the definitions are defined in that cluster.yaml, or the version of Kubernetes that is installed is also defined there. and it allows us to install and also reinstall the cluster of the software of the cluster if we need. So for instance, that run update cluster script, again, going back to the approach of capturing knowledge in scripts, that's the one who will do all the actions to grab any changes to that YAML file, update the S3 bucket of kops, and run the rolling update of all the definitions that might have changed. And you can see an example that I mentioned before, that if you run the script and it needs a parameter, it will ask for it. So it will help the developer, help the user knowing what it needs to fill. But if you already know that, you could have run directly with space dev as a parameter like you do normally, and it would not ask anything, it would just keep and continue. Other setup scripts that we have, a bit of a naming convention that we do, but that's, for instance, if you want to create a new environment for demo, for instance, that script takes care of all the steps of giving you a blank, well, just with the basics, a cluster that you can run to create a demo script. And then you can tweak the version if you want to test a specific version of Kubernetes and things like that. Continuing in terms of Terraform, when I mentioned the extra resources that we need, for running a cluster, we need things. We need, for instance, keys per environment to save secrets. We use AWS KMS for that. We'll see later a bit of detail how we do it. RDS instances, we need databases to support the forms, because we save in-flight data of the user. So when the user fills a wizard until they submit it, we keep that data. But once they submit it, we call the integration points that the developer gave us, and we drop the data. But we need to store it in flight for a while. So we used RDS Aurora database for that. We realized after using it that we were using it more for the managed part rather than the relational part. So now we're transitioning to using DynamoDB because it's a better, more suitable, but it's those realizations that you, once you operate the platform, you know how to tweak it and evolve it. One small thing here also worth mentioning. I mentioned that kops does all the things for you. It creates all the resources, and we also let it create the network, the VPCs. Once you create these extra resources, like, sorry, this is a tendency. This one, RDS instance, it needs to be placed in a VPC that the nodes can see, can access. And so we have this script that creates the necessary Terraform file and imports it to the state, so that when you run Terraform plan, it just can recognize that whatever kops created exists. And it seemed fine. From the beginning, it's a good default. We use it, and we don't need to, the topology that it creates suits us, and it's all good. Until the day we, because of a botched upgrade, we needed to just drop the dev cluster and recreate it. And we went to kops and we recreated the cluster completely, and it recreated the network. And then when we tried to import here, Terraform wanted to recreate the database also and all the resources. So lesson learned, we're going to pass the network definitions to an earlier state, tell kops what kops they must use, and then we control all the network definitions. But again, so learning these lessons is useful, but then we incorporate into the scripts and into the, so there's no document of procedures. There's these scripts in these folders that you need to run on this order to understand what's to operate and change the infrastructure. And then we reach Kubernetes. This is the structure we use. For each type of resource of Kubernetes, we have a file inside the service. This is an example for the deployer service that Kasia mentioned earlier, the one that creates all the images on the Docker images on the fly and all that. And two things I would like to highlight here. So one thing is the deployment of services. So one thing that bit is a bit working with Kubernetes sometimes is when you switch environments, when you switch the context of the cluster you use, that sets changes the setting in your home folder. So it's not per session, it's per user. You have several terminal windows, and you set the context in one to a dev cluster, and on the other terminal window you were operating on local. Now, if you go there and do a command, it will go to dev, not local, because it changed that file in your home directory, pointing it. So, because we were bitten by that mistake a few times, so we scripted it. So this one, for this script, this command is passed directly to kubectl, to Kubernetes. This is just, so it's a pass-through. It's not a wrapper. Whatever you write here, it sends to Kubernetes, to the Kubernetes command line. So, if you write something that Kubernetes doesn't understand, you have a Kubernetes error. So it's cool. And the thing we do here is that according to this folder, this wrapper script looks at the folder name and sets the correct context. So if we're doing dev, it will set context for the cluster of dev. If you do local, it sets to minikube. If you do then test, that's test 3. For the common operations that we do day to day, the routine operations of applying, deleting, testing, trying a new version and all that, when we use this, we are safe that we don't botch environments accidentally. For the more complicated stuff, you can always, kubectl command directly. Then you need to be sure you are in the right environment. We also use this, for instance, for Jenkins. So, as an example, when we do a new commit and we push a new version of the service of deployer, the first job that tests all the code ends creating a Docker image for the microservice for that web application, and then calls deploy Kubernetes. This job service on Jenkins needs to put that code running, that Docker image running on the dev cluster, and it does what we would do manually when we're working locally. So on the deployment for our infrastructure repo, it updates the image to the new one that we want to deploy, then runs this same script to apply all the changes that the service has, make sure everything is up to date. That will trigger Kubernetes to do a rolling update of all the pods, start bringing some pods up, shutting down others, and it waits until all the ones are ready, and then it says it's a success. Us as developers, when we pull, we can see that there were new deployments, and then look at these versions in dev and see what versions we can clone to our local environment. Again, there's a script to do that. Sure, our local environment uses all the versions that dev does, things like that. Finalize, just a note how we were protecting secrets and the changes we're doing. So initially we were using public key, private key to save our secrets. So there was a list of recipients which has the public key fingerprints of all the authorized developers. So then when you run a script to encrypt all secrets, it will use those public keys to each secret file of each service, generate an encrypted version. That's the one who goes into the repository. The plain ones are just ignored from Git. You can never go there. And it goes through all the path, all the directories and all the environments, make sure everything, there's no secret YAML naked and being committed without what being encrypted. And the same thing for the decrypt all script. You run it, and it does reverse. Then another thing we need to save is the kube configuration. So the access to the Kubernetes cluster, we need as also keys and passwords to access, and we need to save it and share that file amongst the team. And for that one, we decided to save it in a different way. So we save the file in S3, encrypted with a KMS key, and there's a good integration for the AWS between KMS and S3, so that when we try to copy the file to our local directory and we say which key that it needs to use, that's where your IAM profile and permissions are applied, and you can, if you're allowed, you can download the file. It's encrypted at rest in S3, and you can easily then revoke and change or roll keys. Gives you more flexibility than the previous way we were doing things. Actually, we still have a mix of both methods of doing it. And for the end developer, nothing changed. It's just running the encrypt all and decrypt all script, because we encoded that, change the way the script to work in a different way for some resources, and then there's no need to, again, documentation, explanation, do a different process for different things. We encode that and hide that in the automation. And I believe that's it. So it's high level view of all the things we do. There's a lot of interesting things to go into more detail with all this, but we'll be here. Feel free to pick our brains, anything you want. And for us, that's it. If you have any questions, anything you'd like to clarify? If we ever tried Kubernetes on Google Compute, no. For this project, no. On other projects, Kasia has before worked with Kubernetes there. It's actually one of we were using a different type of architecture before, the recent move to containerization into Kubernetes. And actually one of our objectives in our roadmap is to, once we have this settled and stable, to try Google Compute as an alternative provider to see if we are not so locked into AWS and have more possibilities. Because one of the drivers also for this change, for this type of architecture, is that not only Google Compute, but also Azure, to see how we can be more flexible in terms of provider. Oh, you mean the network? So you're asking when you move the network out, it wasn't outside of Terraform. We were letting kops create that. So we moved it out of kops into Terraform. So into the first base version that lays out the groundwork also creates the VPC definitions. So then we just tell kops, use these definitions, use these ones. The entire environment, not that often. We do run Terraform plan every now and then, because that already gives us a hint if there's something that we need to change. But we realize that because Kubernetes environment moves very fast, that's a good thing for an open source development, an open source project. That there's a lot of eyeballs on it, and a lot of versions being released, so bugs are fixed quickly. But sometimes upgrades can also be complicated. So we have botched a few, especially on the dev. That's where we experiment things. We have botched a few things. Sometimes we upgrade, and then the network driver no longer works. You need to change it. So we just kill it, restart until we get a way that's more compatible. Or sometimes don't move later environments to the newer version and wait a while. So in that sense, we wanted more freedom to recreate the actual cluster environment more freely. So the question is if locally we use Minikube or if we deploy an entire cluster on AWS per developer. No. So we use Minikube locally, and we have one development environment where Jenkins thing. So in theory, only Jenkins would deploy to development. Sorry? That's what I was going to say. In theory, because in practice, Minikube, it's not really there. There's some things that don't really work with Minikube. We have already had to, when we create the Minikube, we need to increase memory and number of CPU uses because the defaults cannot handle all the things we put there in all the components that we use. The most recent one was we stumbled on defaults for file uploads. It was timing out, and we had to, instead of using an add-on of Minikube, to actually deploy the resource, the Kubernetes resources ourselves, so we could tweak those values and increase them. So yeah, Minikube is still a stone in our shoe. We're trying to explore now, as it's in the to-do list. Docker for Mac now supports Kubernetes, so we want to see if that's a feasible alternative for the plans we have in Minikube, but we're still exploring. The question is if a node of Kubernetes goes down, if we need to run, if we need to run Terraform and kops to get it back up. So in AWS, the infrastructure we have, it's both the masters and the nodes, they are in auto-scaling groups. So the case of one EC2 instance going down, it should be handled by the auto-scaling group. So once you need to schedule more pods to run and they're not sufficient, you get a new one created, new EC2. You can tweak those details and see how big is your pool and the policies to create new ones, but you don't have to create kops to run kops again. Running kops is more if you want to change the version of Kubernetes that is installed, you'll run kops. So you change the definitions, you'll run kops, and kops will do the rolling update of the actual EC2 instances to the new version, turning some down, bringing some up, and maintaining the level of service working. So that will be managed by kops, right? But we don't control right now the details of how many we have. We have a starting number, and we have auto-scaling group, and we let that control how many are created and reduced dynamically. I guess we just scale up. Yeah. So again, it's so far for the needs we've had and the kind of load we have in top and the client we have, it's been sufficient. I guess once we reach some scale, you start getting other problems and other concerns. but we take it the agile way, one problem at a time when it comes. No. So the question is if because we mentioned possibly moving to Google Cloud, if we were thinking of stop using managed services and then moving into Cube. Again, going back to the team being small and need to be agile and lean, let's say, we try to leverage managed services as much as possible. So the idea, when you're going to try Google Cloud, we want to also use the equivalent of those managed services in Google Cloud. And actually, it's an advantage of the Terraform that we invent. One thing that helped us pick Terraform at the end, in the beginning, which is, although they say they are provider agnostic, I don't really like the term. I don't think they are. I think they are multi-provider. So you can create, let's say, RDS databases in AWS very easy, so you have a resource for that. If you go to Google Cloud, that thing doesn't translate. But there is a resource for the equivalent of Google Cloud. So you are in an ecosystem of Terraform plan. You know the tools. You know the documentation is all in the same place. So you are in an ecosystem that allows you to target different providers. Yeah, you need to change the recipes, but you can reuse most of it. So the name that we use constants, we use variables, we use all that to build the names, and we use the modules, so they are always dependent on input variables, and then they compose and concatenate so that the names of the resources, most of them are just automatic. So it's something that Terraform gives us, is that ability. But there is some work. It's just not grabbing what we have and pointing to Google Cloud and hope it works. So the question is, because whenever we deploy a form, we create a new JVM. If that's an issue because due to the number of resources that run on the JVM, it's resources. You need to scale it will affect the scaling that we do and the number of machines that we need to turn on and enable to support it. You might, on the other hand, we might think, okay, if we have just one executor in one JVM that could handle all the forms, you could optimize that, right? Yeah, or other languages. Language is more of a change. Once you start, we are already too committed on the JVM. And optimizing it on the way, like a central executor that can handle many things, that was actually the initial architecture that we had, which has other issues in terms of client isolation and trade-offs when we want to become multi-tenant and all that. And that's one of the things that drove us to explore this type of architecture more containerized. So a JVM makes each pod consume more resources rather than just a scripting or executable compiled language. Yes, but at this moment is the life that we have to. No, but it's not that complex because it isn't doing a big. So the work it does is fairly straightforward. So it's quite simple. There is some time on the execution. Most of it is not computationally intensive. That's what I mean. It's more like So when you receive a request, it needs to compose HTML to send back, right? So that is to fetch theme and mustache templates to render. So those are very light. So you could get away with bare minimum that you can on JSON. Okay, thank you.
So we'll do just the raffle, and then we'll do the open space. So I'm going to cheat and do the raffle here in my phone. So the lucky number, hopefully, is 23. Does anyone have 23? Yep. So this is for you. Thank you. So now we are going to do the open space, and the open space basically exists just to facilitate